So do you know, guys, why large language models hallucinate and give incorrect information, and how RAG can remove that hallucination from large language models? So in this video, I'm going to explain you all of this. So hi guys, welcome to FreeBirds View and welcome to the RAG playlist, in which I teach you about RAG plus LLM with different domain projects from basics to advanced level. This is the first part of the playlist in which I explained about RAG and tell you about its architecture and how RAG actually works. And at the end of this video, I also create a RAG plus LLM sample application using Python and LangChain as well. So let's get started. So do you know why we use RAG to improve the large language models? Okay, so let's just take an example. We have a chatbot for customer support in the electronics department that is powered by large language model. But is this chatbot always work? No, because it cannot answer those queries on which it was not trained and the products that it don't know. Okay, so that's because of lack of information. It hallucinate. It gives the generic information only and incorrect responses as well. How do you solve this problem? The answer is RAG. RAG is a retrieval augmented generation framework that combines the capabilities of a pre-trained large language model with an external data source. It did it by storing the data in the external database, usually a vector database or the NoSQL database only. Okay, so now you have the large language model with its context, with the query that helps to get the better response. Okay, so now let's talk about the RAG architecture. So when user gives a prompt or a query, it goes into the data augmentation layer. That means it converted into the vector embeddings first, then the retrieval engine that contains the external data, and it is stored in the vector DB as well. So with the help of that, it searches the input prompt embeddings in the vector DB and find the similar kind of a context or the information that is present in vector DB, that is called as a context. So when we get the best ranked output from the vector DB, it is aligned with our input prompt, and we have now prompt and its context, and that whole package is passed to the generation phase, where we have the large language model that can help it to generate the better response as well. With context given, it generates those responses correctly and in a better way as well, and it also gives the answer to those questions on which the large language model is not trained as well. So let me just show you the full flow of the user prompt to the response generation with RAG. Okay, so here you see is a complete flow of how the RAG works. So the first part is the data collection layer. We collect the external data and then we chunk it. The chunking is the most crucial process that we covered in our next video, and then we create the embeddings. From the chunking to embeddings, after creating the embeddings, we store it into the vector DB. It can be any kind of DB like Chroma DB, Pinecone DB as well. Okay, and then whenever a user raises a query, also converted into the embedding as well, and that embedding is compared or like a kind of a similarity check with the vector DB embeddings to find the similar kind of context, and the top ranked context are fetched from the vector DB and aligned with our input prompt as well. So that means we have a prompt, we have a context as well that is passed to the large language model, and it will generate our final response as well. Okay, so that's how the complete RAG framework works. So and here are like some kind of practical applications of RAG, that we use it in the text summarization, we use it for the personalized recommendations as well, we get for the shopping, for the investments, and for many more things as well. We also use it for the business intelligence as well, where we use it in our many kind of industries like finance, retail, and so more, and we will cover all of these practical applications in our upcoming projects as well. Okay guys, okay. So now let's build our first RAG plus LLM application using LangChain and Python and Chroma DB as well, in which I use the BBC News Dataset. This project provides you the complete overview of GenAI based project structure as well. So this project follows this kind of approach of the data ingestion that we call as that data augmentation as well, and it takes the BBC News dataset, creates the embeddings, and then store it into the ChromaDB as well. And in the retrieval and the generation phase, we have the prompt, we convert into the embeddings, and then we compare it with the ChromaDB embeddings as well, find its context, and then pass it to the large language model. So in that way, completely works. So let's go to the full code here as well. So as you just see my screen, here is the my collab notebook is here. This is our full project structure. Goal is to create a retrieval element system that accept the queries and generate the contextual responses as well. Okay, we have the data of the BBC News that contain the description and the tags as well. So whenever you load this kind of a data, it has the 3 columns: news ID, description, and the tags. We will just first clean our or pre-process our data as well, and then we start our data ingestion process. We first is to make that data into the document format, because a ChromaDB only accept the document format data. So for that, we just first load our document format here and then make a documents list that contain all the document format rows as well. And for that, we run a for loop on our whole data and put all the data into the document format and append it into the documents list as well. Okay, then we install our ChromaDB, and this is how you install it, and this is how you load it with the Hugging Face embeddings, because we have to embed those kind of data as well. So for that, I store this kind of a DB in this local path. I pass my documents list, collection name along with the Hugging Face embeddings as well, and then to store it as well. So so this is how you can load the external data, convert it into the embeddings, and then store it into the vector DB as well. So now the next stage is retrieval and the generation. So where we have to load a large language model. So I use the Zephyr 7B large language model. So you can use of your own choice. Okay, and I load into the quantized format as well. If you don't know about the large language model quantization, you can check the video in the I button as well. You can also follow my 75 hard generative AI playlist as well. Okay, so I load my model, load my tokenizer as well, and then I just make a query pipeline of the text generation that accept the model and the tokenizer along with the max new tokens of the response as well, and then make a large language model function that will accept my prompt and my context to generate the response as well. Then I have to find the context from the ChromaDB as well. For that, I make a retrieval QA chain. So the chains are the concepts in the LangChain that can help you with the RAG framework. So we make a chain of the flow that has the vector DB, then the context, then the prompt, and then the large language model. So we have to make a kind of a chain kind of a system here. So for that, first we make a prompt template here that take our query and our context and generate this whole kind of a response as well. We make a retriever out of your ChromaDB here. Okay, that will give you the best 3 responses out of your ChromaDB, and we pass it into our retrieval QA chain that accept the large language model, our retriever, that is our ChromaDB retriever, and then get our prompt as well. Okay, so in that way, this is how the retrieval QA chain works. And then when we pass our prompt or our query into this kind of a chain, what does the data say about the sports news? And then it will try to run it. It will find the best 3 responses, make a context, pass the context and our query into the large language model, and it will generate the response. So as you see, it will give us this 3 kind of responses here, and then this is how the answer will look like. Okay, so that's how you can build this whole kind of a complete project by using the RAG framework, using the LangChain and Python as well. Okay guys, I hope you completely understand that how it completely works. Okay, and in our next video, we'll talk about the chunking strategies. The chunking is the most crucial steps in building a RAG vector DB with the external data as well, because you know how to chunk your data so that it can give you the best results and best responses as well. Okay, we will know how the chunking works and what are the different type of chunking strategies that you can use to get the best response out of your data and build the best context for your prompt as much as possible. Okay, if you want to know about the generative AI, prompt engineering, or machine learning, you can watch my videos on YouTube and also read my blogs on Medium. We'll meet in our next video. Thank guys. Thank you so much.